Okay, good morning, everyone. Welcome to Data Core Systems Automation Practices Philly Tech Week community event. First, we would like to thank Comcast and the Technically Philly Tech Week crew for making this event possible, especially this year. A couple of housekeeping items before we begin. If you could please mute your microphones during the presentation and demo, and please submit any questions through the chat function, and we will answer as many as we can at the end in our Q&A session. Also, our event today is being recorded. Our event is on automated machine learning, leveling the playing field for SMBs. We have had the privilege of talking to many clients and prospective clients about a plethora of use cases for our AutoML platform, from COVID-related issues to retail, needing to put their data into action and predict outcomes more accurately. During our virtual event today, we challenge you to think of some use cases for our AutoML platform. With that, I will introduce our speakers. I am your host today, per se, Amy Hastings. I'm the Tactical Marketing Manager at Data Core Systems. Shangramitra Ghosh, she's the AutoML expert. Abhijit Chakrabarti, he's the IT practice lead. He also handles the entire automation practice. Then for our Q&A session, we have technical panelists. Joydeep Banerjee is our AI technical strategist. Anish Tulakar is our AutoML lead. And Ronak Mazumdar is our machine learning engineer. With that, I will hand it over to Abhijit.
Thank you, Amy. Thank you everyone for participating in our today's initiative, which is AutoML for the SMBs. But before I start the main topic, let me tell you that Data Core New Age Automation Practice actually is made for SMBs, and particularly the situation where we are and the resource dependency, the problem with the visa, everything is actually driven by this initiative where we are offering new age automations for 5 different areas. So one is hyper automations. That's kind of most of the automations where you can implement automation. That's kind of hyper automations. So people have like confusion with the term, but your software testing automation falls under this category. Second is your AutoML, which is automated machine learning, which is today's topic, and we will be covering up this topic very well. Third one is security automation. Security automations, mainly with the application level security automations. That's another service what we offer. And the fourth is automated data management. So whatever you do nowadays, data is mostly important thing, as you all know. Storing the data is one challenge, but flowing the data into your system from one place to another is another challenge. So that's another topic. We provide that kind of service to automating the data in different parts of your architecture. And the last one is RPA, robotic process automation, which perhaps you have seen companies like Automation Anywhere, Blue Prism, UiPath. We are also their partner. We also use some native approach to solve the RPA. So that's kind of the technical offering from our side. But today's session's AutoML, this is one analysis of the cost what a company, especially say in New York or Philadelphia area, New York will be a little higher, of course, is spending. So if you want to initiate a machine learning job, it's not that you need to recruit data scientists. You need to have a data engineer to process, prepare the data. Then you have a data scientist who will be doing the machine learning thing for you. Then you have a data analyst. Before you do machine learning or data processing, they need to do the analysis part of the machine learning. And then when everything is done, then you need a visualization expert so that you can create those dashboards, KPIs in different platforms like Power BI, Tableau, ClickView. So it's not only machine learning for any particular industry, and it's expensive. It is just an estimate to show you that it's kind of 500,000 per year for like four resources. And the chart is saying that if you go ahead with the DCS AutoML platform, it's kind of 211,000. Actually, it is statistics, but it's far below that 211,000. That you will see today that why it is far below of that amount. So this is just a cost estimations for the small and medium companies. This session is not actually made for small and medium companies. It's for everyone to learn about. But you know, the most benefit we can provide to small and medium companies, because we know that they don't have huge money always in hand, and not only is money, is also the resource. Let's go to the next slide so that I can explain the resource problem. So now, as you have seen and already started working on use cases using machine learning approach, and the traditional approach, as I have showed you, that you need different kinds of resources. Just focus on data scientists. So data scientists are expensive. If you really get a true data scientist from a very good institute, very good educations, and they are expensive. But now what is happening? One problem is that the visa situations, the resource shortage, plus what attrition is there. So you're going to lose an experienced resource from your team, and that's the challenge. And I have seen that a lot of job postings are happening. They are requiring citizens and green card. Why? Because if they hire someone and then they leave us, they have a problem maintaining their system. So coming up with automations, coming up with automated machine learning, all is going to address different aspects of our daily work. It's not only solving a machine learning algorithm automatically. It's not that. So you will see that this session is not to tell you that, you are doing machine learning, I can do it automated way. That's not the purpose of this whole session. It covers a broader aspect of our industry, a broader challenge it covers. That you need to understand from this session. And then later I'll come back. Sanghamitra, my colleague, will explain the platform, what we build, and the purpose what we build. So let's go to the next slide. So this is kind of our AutoML platform, which Sanghamitra is going to demonstrate, and she's going to talk about it. Go to the next slide, please. So here you will see that why we created this DCS-AI AutoML platform. So there are few points which you can read. I'm not going to read each and every line. Rather, I like to say why, other than this 7 point. Number one situation is your assessment. Say you are thinking about a use case. You are planning to do some machine learning. You think that this needs machine learning, but you are confused. Your IT head and you all are discussing, like, to do that, do I need 4 people in my company? Do I have to spend $500,000 in a year only for assessment? Answer is no. This kind of platform can help you to do assessment. And whatever the result outcome you can see, later you can decide whether you will invest or not. This is the first advantage of having this kind of platform. You are just paying $5,000 to a company like us, and then you just assess whether it is a possible use case or not. Otherwise, it may happen, and it happened already for different companies that they invested $1 million, and at the end, they got like 53% result. So 53% result is what? Nothing. It's 0 or 1. Why should I do machine learning? I can tell you that it will yes or no. So those kind of situation you can avoid using a tool like this. Second point is comparison. So I hope a lot of people are here who are a data scientist, probably working in the machine learning. You have already seen that a particular use case, one person is following a random forest algorithm technique, and the other person is saying, no, let's do a deep learning CNN technique. And the other person say, let's do something else, XBoost or other algorithm. So it may happen that each data scientist can come up with a different technique or algorithm once the data is stable, and they may get a different variations of their output. And then they decide that what is the best output. So for us, we have solved another problem. Running an AutoML is so good and so beneficial that you don't tell the tool to which algorithm to choose. One AutoML platform runs against 10 to 15 different algorithms to see what are the outputs coming up. And what we have done, we have different platforms all together. So you can getting outputs from other, think about different, you have given a job to different companies. You have given a job to Microsoft, you have given a job to Google, and you are getting their output and spending it like $5,000 to $10,000 cost. Even if you have a Azure expert in your office and who can create everything for you, but whenever you are stuck, what you're going to do? You don't have machine learning expert, then you have to contact Microsoft support people for 3 hours or 4 hours, and you have to pay for that. So, but here it's a platform as a service. You pay only for the service what we provide. So Datacode is not going to provide only an AutoML platform. It will provide different AutoML platforms so that you can have different algorithm run, different results. It's so simple, and also Datacode team can support. And the other thing is, if you are stuck with a specific cases, like it's not AutoML normally supports supervised learning, but for unsupervised critical cases, you are saying, okay, I was using AutoML for supervised. Now I have a critical case. Do I have to again bring data scientists from the market? No, we have a team of separate team with data scientists. Ronak and Joydeep both are here. They are part of that team. They can do the traditional machine learning as well if the case is so complex. So we have seen that 90% cases what we are getting from the client, those are mainly supervised. They are historical data, and AutoML run fantastic, very close to the traditional way. So you will see from Shangamita that how good is the tool, and the comparison part, it gives lot of benefit. And the other part I have already addressed, like if you bring resources for one project, when the project is over, what you're going to do with the project? You'll ask them to leave. It's not good at all. It's not a good policy of your company to bring people and ask people to leave. Why should you go into that route? Let's have a platform, use the platform, pay for the platform. Once you're done, just fine. And the last part I must tell that it's not about, as I said, not about doing machine learning. It's an end-to-end life cycle. That's why when I will explain the case study, you will see that Datacode is not a company who provide AutoML or machine learning. It's a part of like data cleaning, processing, storing, machine learning, visualization, all included, and the deployment. So when the machine learning will run in production, how are you going to manage that? Who is going to deploy that? How are you going to monitor that? There are resources need, and why should you spend money on those resources? A company like us can also solve that problem using a platform like this. So that's all from my side. I am trying to just explain you what is today's topic, why we have mentioned only SMBs. Actually, it's for all. We have targeted SMBs because we know that SMB companies has problem especially after this period of pandemic. We have all are in a problem with financial crunch, cash problem. So it is a great help to the company, and that's why we are getting a lot of calls from the companies, especially SMBs, that they need help from us. So that's why we thought, let's present the whole topic to this session. This is our second appearance in Philly Tech event. I hope you will all not only like it, you will all get benefited from this session. And we are happy to help you in any projects, any proof of concept later. You can contact us. So that's all for my side to start this session. I hope you will enjoy. Shangamita, now you can proceed. Thank you.
Thank you, Abhijit. Hi, everyone. Welcome to our session today, and welcome to the world of DCS-AI AutoML. So this platform, what we have in our company here, you will see we have 3 standard interfaces, AutoML interfaces. Along with that, we have DCS AutoML. And that's not all, as Abhijit said, it's just not AutoML, but you're going to have a bonus customized machine learning too. So this platform covers both AutoML as well as customized machine learning. And along with Azure, Google, H2O.ai, the standard AutoML interfaces, you're going to benefit from Datacode's AutoML services too. And where the complex supervised and unsupervised machine learning is not possible through AutoML, or you want to do something more traditional, you can always come to us for customized machine learning services. Due to time constraint today, we will share with very few interesting and important sections of the pipeline so that you may get a flavor of the robust yet simple tool. You can connect us anytime later on. If you're interested, contact information will be shared at the end of the session. So data scientists, analysts, and developers across industries can use AutoML to implement machine learning solutions without extensive programming language. You can save time and resources, as Abhijit said, leverage data scientists' best practices, provide agile problem solving. Now, for our time constraint today, what we are going to do is mainly we are going to cover very descriptively the Azure AutoML. And for Azure AutoML, we have prerequisites like data must be in tabular form, data must be labeled, and the value to predict and target column must be in the data. So though we are going to cover completely the Azure AutoML from a platform, we are going to have a demonstration, you're going to see the Azure AutoML. But even then, we are going to very fast breeze through the other three interfaces that we have in a platform, that is Google, H2O.ai, and our DCS AutoML. Now, if you look at the pipeline, you will see that this is a machine learning pipeline, starting from infrastructure to deploying model and monitoring. Now, this pipeline, this AutoML pipeline is actually built into our platform. The steps are separate. As we go through the demonstration, it will be very clear to you. The steps are separate, but you will see that the Azure AutoML, when I explain that, you will see the infrastructure covers the workspace and the compute. The prepared data covers preparing and uploading your data set. The train model, the package model, and the validate model from the pipeline. It's going to cover the most important, that is the AutoML experimentation. Deploy model will cover the deployment. Monitoring will cover the monitor of the entire pipeline. And you can predict at any point of time when your model is ready. Now, when you look at this pipeline, I have to mention one thing, that you have to understand that we are sharing with you today only the AutoML section from a very wider pipeline. To get a better understanding, you should know that we have an end-to-end automated data management team for data cleaning and data processing, who actually handshakes with the automated machine learning team for machine learning and predictions. And finally, the predictions are sent to the visualization team for interactive, dynamic, analytical dashboards in Power BI. And also we have expertise in Dundas BI, Tableau, but the focus that we have from this platform is the Power BI visualization. So this middle section, what you see the pipeline over here, this is the AutoML pipeline. And if you see previous to it, we have the automated data management. I'm emphasizing on automated because it's an end-to-end automated pipeline. And after the machine learning, we have the visualization team. So now let's start with the demo. If you have any questions anywhere, please put down in the question chat box, and we are going to come into it in the Q&A session. So welcome to Data Core Systems AutoML platform. We are going to log in into a platform. And once we have logged in, you will see the home page where we have already shared once in the presentation. We have the three interfaces, the Azure AutoML, the Google AutoML, H2O.ai, and DCS AutoML. Along with that, we have the bonus DCS Customized Machine Learning. So we are going to delve deep into this session with Azure AutoML, okay? The AutoML pipeline, the Azure AutoML pipeline, you can say, is in sync with the steps that I just now described to you from the slide. That is, it's computing, experimentation, deploying the model, using the model for prediction, and monitoring the overall process. And I have even explained how the AutoML pipeline has or is in sync. So let's start with creating workspace. Now, what is the workspace? It's just like form. It's very easy for any end user. For each of the steps, you will see it's a form-like thing where you have to provide few inputs, just selection from drop downs, and the step is ready to go, and you can proceed to the next step. So we have started with creating workspace. Provide a unique workspace name, resource group, subscription ID as registered in Azure, location to create your workspace. You can say that this is a container where the rest of your steps of machine learning will actually be cooking. This is where you're going to upload your data set and access for the next steps. Once your workspace is successfully created, you can see a preview, and once you are ready, you can go to the next step of computation. As you can see, for security purposes, few of the few of the forms or few of the values in forms are blurred. So please do excuse, it is for security reasons. So when your workspace is ready, we come to create compute cluster. You have to select a scalable VM size. Now I emphasize on scalable or give you an idea of the robust or thinking of our platform. Now, if you are aware what kind of experimentation you're running, if you are aware of your data and you're quite have hands-on experience with it, you can easily select whatever you want to, or you can change the parameters from the forms here. But if you are not that expertise in what you're doing, this platform is going to help you with default values, or you can select from drop down and proceed with ease. You do not have to worry about the hard work behind it. It's going to do it for you. Now, once the scalable VM size is depending on your volume and how complex your algorithms are. So you're going to give a cluster name and you're going to select your cluster category. Cluster category is something that needs a little bit of understanding. You can see we have training and inference. When you're doing training, as we have for this demonstration purpose, we are going to select training. If it is for production or publishing, you're going to select inference. So once your compute is ready, you're ready to go to the next step. That is uploading your data set. Now, first, of course, we are at least aware of this much. Now, let me tell you, I'm also not an ML expert, as you say, as a high operative data scientist, but I know what I'm doing. So what here happens is, here you're going to select your, you're going to upload your train data set, okay? So in our platform, as of now, you have four options to select from. You can either upload your train data set from local system, or from Azure Blob Storage, or an Azure SQL connector, or from data lake. So for demonstration purpose today, we are selecting a sample training data set from local. So once you have uploaded the data set, now you should remember one thing, that as we said, there are prerequisites. So your data should be labeled. And when it comes to the preview, I'll show you what is the labeled data that we have used. This is the preview that you see. Now, our labeled data is a label column, which is churner and non-churner. What is churner, non-churner, or what this experiment will do, I'm going to come later on, okay? So we are uploading the training data set, and once it is uploaded, comes the most important part of this pipeline, that is experimentation. The AutoML experiment actually has, internally, it has 4 sub-steps over here. Again, it's form-like, you do not have to worry much about it. It's going to, the form itself is going to let you know what you're doing. So the 4 steps are environment setup, data preparation, experimentation, and deployment. These are the 4 steps of the AutoML experimentation. So select your experiment name, select the workspace that you had originally created or initially created. Now here we have taken a classification scenario, okay? It could be classification, regression, forecasting. So for us, it's a classification scenario of churner and non-churner. And then you're going to select the data set that the train data set that you had uploaded. So your setup is ready, your data preparation form is done. Next, we are going to go into experimentation, okay? Now, automated machine learning trains multiple machine learning pipelines, okay? Each pipeline training is known as an iteration. So you have to select again few parameters, like you have to select metric, number of iterations, which you're going to see just now. This is the data set that we are showing once more, okay? So when you go into experimentation, you have to select the metric, number of iterations. Again, may I repeat that for us here, the primary metric is accuracy. And again, if you are not aware of what you are doing exactly, you can keep the default values as is, or you can change them if you know what you're doing or you're familiar with it. So giving your iteration time, experiment time, and the other parameters, you're going to start your experimentation. Now, this experimentation is most important because what it does is you just click on train, and that is just what you have to do. But internally, what happens is internal preparation like feature engineering, factorization, encoding, all the hard work is done. It takes place at a point, but internally, and you don't have to worry about it. It runs on multiple algorithms and comes out with the best results. So let's start training. Once your model has been created successfully, you can see the algorithms, okay? So here for this experiment, you can see stack ensemble, voting ensemble, SGD, RF, random forest, and light GBM, etc. has been run. And so you can say that though AutoML, you don't, as I'm repeating that you don't have to understand anything or you don't have to do the hard work, it's going to do for you. But then you see it's not a black box entirely. It is actually giving you a picture. It's giving you the transparency to show you what algorithms are being run behind the experiment so that if required, you can change the parameters, you can do hyperparameter tuning and make your model better if necessary. Next comes deployment. So the most hardworking is done, experimentation is done, your model is ready, your best fitted model is ready. Next, we are going to go into deployment. Now, deploy, you can say, is the model is a container, okay? It's a container that will allow you to run your model code, that is your winning model, on a specified environment. Now, here you see that you can see a unique run ID, okay? This unique run ID is going to actually give you that deployment URI, that API URI. And if you see, we are selecting a deployment method, AKS and ACI. So depending whether you're training or you're publishing your model in production, you should select ACI or AKS. For training purposes in this demonstration, we have selected ACI. Select your service name and then deploy your model. Azure Machine Learning Services has pretty awesome functionalities included in automated machine learning services that will do the work for you when deploying. It will deploy your best model. It's on the leaderboard page which you previously viewed so that to see how different models are performing. When you deploy the model, Azure Machine Learning Services generates an endpoint, that is the unique URI, as I said. Now here you see that again I clicked on deployment. Now this deployment on the tile which I clicked just now, this deployment and the deployment on the fourth step that you had in experimentations, it is entirely same. It is not that you have to do deployment twice. Why we have kept in our platform the deployment twice is, if you're doing the experimentation for the first time, the 4 steps will cover the deployment too. But if your model is already ready and you are deploying it at a different point of time, your model is ready, but your experimentation maybe was done 1 week ago, you were satisfied with the results, and you're doing the deployment at a later point of time. So we have kept a deployment tile on the home dashboard itself for Azure AutoML so that you do not have to go into that experimentation process or the 4-step process, but you can easily deploy it as and when required. But the steps are entirely same. You do not have to do anything extra which you did in the 4th step over there. This is just to show you that it is the same. You're selecting the same. You're selecting your ACI or AKS depending on training or publishing. And then finally, you can deploy the model whether internally from experimentation or from your Azure homepage, Azure AutoML homepage. So once you have deployed successfully, okay, let's complete this deployment and then I'm going to come to the next section. I hope everybody can follow and I'm not too fast. Please do put in your questions in the question box, okay? You can see a preview of your deployment, okay? And you can see that URI 2. Yeah, see? You can see the REST endpoint. So once the deployment is complete, what next? Next, what we have is monitoring. Now, monitoring, if I can say, or if I may be bold enough to say, that it is not exactly a pipeline of the AutoML or the machine learning, but it is a step which you cannot skip. Because unless you do a health checkup, unless you know what is the statistics, how is your VM doing, how is your CPU doing, do you need to do some other tuning? Do you need to do any cleanup process? If you do not do these, your your AutoML or your machine learning is not going to work as expected. So for highest performance, monitoring is an important step which cannot be skipped. So other than that, finally, what is left over is maybe not the most hardworking part, but the most interesting one, that is prediction. So your model, your best model is ready. You have trained your data. Now you have to test to see how accurate your model is. So we have uploaded a test set, okay, and then you're predicting. If you remember, the label was our label data, that is churner and non-churner, and the prediction. Once you have done the prediction, you will see a new column at the end, that is the predicted column. So label churner, non-churner, again predicted or prediction is the churner, non-churner. So you can compare these columns and find out how accurate or how good or which were the correct true positives. You can download this result as is, share with your client, or sit in your conference room, make decisions and let your clients know. Or you can use this output to make or to develop dynamic dashing dashboards in Power BI, Tableau, whatever you want to. You can project as required. So we have completed prediction also. So what next? Now, once you have done your experimentation, deployment, all, you have done everything, you have run it one time or maybe twice, maybe you had to run it multiple times, fine. But at a later point of time, you need to view or summarize what did we do in that experiment, okay? So that means you do not have to go through those steps again and again. We do have dashboards or we have screens where you can actually view the experiment details, view the information and make later decisions. You can have the information, the iteration list, the data guardrail to enforce best practices without slowing down or impacting typical operations, enabling data to be used in certain ways while blocking unauthorized usage. You can see the confusion matrix. You can come back any point of time to these screens and see which you can select your experiment, and for that experiment you can get details on this, which is very, very important. You cannot do it just once and forget about it. And you can see the feature importance, global, locally, the influencing factors. So these are the important sections which actually makes you better at a later point of time when you study on these summary or statistics. So actually, I'm trying to give you an overview that it's just not automated machine learning or machine learning that is done by a platform. It covers the other aspects which are as important, like monitoring, summary, getting detailed information at a later point of time to show you that it is transparent and not a black box. So this is what we have for your Azure AutoML. So now very quickly, we are going to breeze through the other interfaces. You can very well understand that your uploading your model, uploading your training data set, generating your best model, predicting, these are the few fundamental things that you're going to do for any machine learning or automated machine learning. So the steps are also kind of same. The only thing is that, like when you come for Google, you can see you need to create a bucket, upload data set, experimentation, prediction. For Azure, you created a workspace. Okay. So the steps are same, but it just varies depending on which interface you're working on. Here also, you can clearly see that you can see the experimentation name, what are the algorithms that are running, what are the hyperparameters that you need to tune, or you see your feature importance. So everything is covered in all the interfaces that you see in our platform. Just a few, maybe you can say keywords are different, or maybe a little bit tweak here and tweak there, like creating workspace or creating bucket or creating cluster. So these are the differences in the different AutoML interfaces that you see in our platform. So you have seen Google AutoML, and we can go to H2O.ai. For H2O.ai also, you will see that you're going to create a cluster. So there it was workspace, then it was bucket, then it is cluster. Again, you have to upload your training data set, generate model. And again, for H2O.ai, you can see the summary, you can see the details. So that is how our platform has made uniform, it is made sync, it's made easy and user friendly. And for DCS AutoML, you can see we just have two steps, that is create your AutoML experiment and predict. And this can be highly specific to customer needs for the DCS AutoML. Now coming to the dashboards. So here what you see is I told you that I'm going to come back to churner and non-churner, what we did. Now it is basically retail domain data set where we were trying to predict whether customers will churn or non-churn. That is, they're going to leave the company they are residing with, or the vendor they're residing with, or they're going to be loyal. So getting this point or understanding the threshold when a customer is likely to leave, once he has decided to leave, you cannot bring that customer back. Okay. So understanding the threshold when the customer can churn, can leave you, that is very, very important. And if you can do predict that, what you can do is you can give promotional offers beforehand to keep the customer satisfied, happy, and retain them. So that was the idea for this demonstration or this experimentation that we had done. And in this visualization in Power BI, what you see is, you can see there are 4 Azure AutoML, Google AutoML, H2O.ai AutoML, DCS AutoML dashboards. Okay, the dashboards are same, only the values are different depending on from which experimentation or which prediction we have pulled the data from. First, we did the AutoML from on the 4 interfaces on our portal, and then the results we have shown in Power BI on these dashboards. And what is the special benefit? Why 4? Now, I'm not limiting it to 4. You can have more interfaces. For now, in our portal, we have 4 interfaces. Now, what happened is when we started maybe 2-3 years back, when we started machine learning in our company, one of our customers, it is a hands-on experience, ladies and gentlemen. So one of our customers, they became skeptical that we were getting too good results. So we were faring about 74%, 75% of accuracy level. So he was skeptical that how could he trust this data to put into production or to show it to his client? What if it fails when the actual data comes in? So that's when this idea came in, that if customer is skeptical, it is true. You're predicting, like tomorrow if it's going to rain or not, it's still a prediction. So either it's going to rain or not rain. So your prediction might match or might not match. So it is it is actually very fair for the customer to be skeptical. So that is the reason this idea came up, and we have this portal against 4 interfaces as of now, where we can see or we can compare what are the percentages, accuracy level, model, which is the best fitted model, which algorithm is working fine for each of these interfaces. We can compare them, and hence we gained confidence, not for us, even for the customer. If we see that Azure is saying it's a 69% best fitted model accuracy, and Google is saying it's 20%, we are skeptical then. That means, did we do something wrong anywhere? Do we have to rerun and find out why the model are so varied? So this is how it helped us in these couple of years. How do I put it? To make this portal more efficient. So that is where we are now. So we are confident, and we have seen, for as you will see, Abhijit is going to show you varied use cases just few minutes from now, where the domain is also varied, and where we are seeing that we have successfully seen that the percentages of best fitted model accuracy is quite near. And not only that, finally what we saw is the customer can not only compare these interfaces results, but they can go for a comparative study on all 4 and then take a average. So they can have not only 4, you can say they can have 5 results which they can compare with. And we have even faced like this customer who is more confident in Azure. So they say that we are going to run only on Azure. So they had the options. We have these options in our platform to go through it. So this is the now we are going to go to the comparative study. As you can see, all four, as well as the comparative study for 73.67%, are directly shown at one glance to you to see what is happening. And of course, you can always go back to the portal for each of the interfaces to see the summary, the iterations, the details, the confusion matrix, the feature importance. So it is, we are very comfortable with it now, and we are growing on this platform. So I hope I could give you an overview on this, okay? So on our platform, and I hope I could make you understand. Again, I repeat, any questions, please put it in your chat box. Now, after we have done this, what I'm going to go again, I'll just take another minute of yours to show you how DevOps and ML Ops has been integrated into our platform, okay? So let's proceed. So before that, we are going to sign out from our portal, and then we are going to go to the DevOps. Okay, so ML Ops with Azure AutoML. The Azure DevOps pipeline to perform end-to-end ML Ops pipeline. Let me repeat this statement. Azure DevOps pipeline to perform end-to-end ML Ops pipeline for fast training, operationalization, and execution of your ML models. Hope this video session was interesting with urge to know more. Confusions and questions are good, and you're always welcome. We are going to go to the case studies now. Thank you so much, everyone. Abhijit?
Yeah, thank you. Thank you,
Yeah.
Shangamitra. I hope you already got so many questions for us. We are ready to answer as much as possible. Just to give you some idea, before I end these sessions, like this is not kind of a tool which is used for proof of concept only. Though we have used for proof of concept for many companies, but in real life also, the AutoML platform is used, and in various industries, finance, retail, healthcare, telecom, parking, and manufacturing. And I will show a few slides where you can see that it's not only AutoML what data core has performed, it's more than that. Can I go to the next slide, please? So this is one manufacturing example, and you have seen that data preparation is done using a tool like Trifecta. Probably some of you know about this tool. It's a very fantastic tool. We are a partner of Trifecta. It's a very growing company. It's an AI-enabled tool we use for data preparation for different projects, government and private. Look at the machine learning process. So we have used AutoML, Azure, H2O, Google, and DCS, and look at the algorithm, the top best. I'll explain only one slide because other slide looks very similar. You will see that Azure, for a specific case, Azure use random forest, whereas the Google is use GBM, or H2 has used a different algorithm. This is possible. So if you have 3 data scientists in your office, one person will be, they will be forcing you to use random forest for a result, and another person may come up with another algorithm. So that is possible, and the advantage is here, we are not doing it. It's the tool who is deciding on the algorithm and the metrics and the feature engineering, what kind of feature engineering, because we have to see one part is data processing, which should be done before it comes to machine learning. And there are some other analysis which we normally do, as Shangamitra explained, like feature engineering, another part. That is actually done by this AutoML tool. We are not doing anything. And the visualization tool, we have used MS Power BI. So that's the kind of end-to-end solution we provided to client. Instead of using a traditional machine learning process, we have used AutoML. And this is another example in the healthcare. So I don't know, there are people from different industries in today's meeting. So if you're thinking about any use case in healthcare, the tool is not any industry dependent. It can run against any dependency. Only thing is, mostly it is supervised machine learning part, and you should have enough data to do that. That we can always help you, that whether you have the data to do that or not. The same thing, the algorithm is different in different platform, but what benefit you are getting, we are getting different outcome. So you don't have different data scientists to perform all these things. and the visualizations Power BI. That's kind of retail. So now you see that this project, after this project, we have also experienced using the traditional ways of machine learning. Just like in this particular case, we have used Azure Machine Learning Studio. So it's not AutoML. Azure Machine Learning is different. So we have experience using that. And the next slide, please. We have used Python. Data preparation is ADF, Azure Data Factory, which is kind of building your pipeline and data lake. We are a Microsoft Gold partner. So in most projects, we use Azure Technical Stack mainly. But data processing, you can also use Power BI for data processing. Now everything is available in many places. You have to just know where it is available, how much cost is this. So that's why a company like us can help customers. And this is again a native Python code based, just like the college grads and the scholars are using Python. We have done the same thing. This is another project for parking inside. We have used time series forecasting with Prophet. I hope some of you are aware of this term. So we have used just data preparation is done in SQL Server. And nowadays SQL Server 2009 is so strong, you can even do machine learning inside SQL Server. So now you have many things available in front of you. It depends on what you are thinking, what is your goal, and how much cost and time you have. I'm going to stress the last word before I end this session, cost and time. So let me go to the last slide. This is another project where it's an old one with HD Inside and SQL Server kind of big data, where we have used SQL Server for the statistical analysis. It's another project with telecom where exactly what Changamitra shown, churn analysis is also is good for them because they want to see the customer retention, how they are keeping the customer. So you can see that the message is very clear that this company DataCore was doing machine learning in a traditional way, just like the college grads are doing, just like other companies are doing using data scientists. But suddenly we shifted towards AutoML platform. And the reason I must say is cost and time. Because if you see the today's topic, we have set up today's topic is working machine learning for the small and medium-sized companies to save cost and time. Let's end this with this line. Say, it is not always better results needs more money. Like we all know that if you are doing decision tree, the expense to run decision tree algorithm is much lower than to run a CNN. So deep learning is more expensive because it needs more infrastructure, more computational power, as you know. So you always say you need better result, you have to spend much more money to get a better outcome. But here, what we have realized using AutoML platform, especially our tool and our services, a 6 months project, a 6 months machine learning trial and error exercise can be done just in a single day. Just note my word, 6 month machine learning algorithm related experiment, all these things can be done in one day. And that's the time saving. And regarding cost, if you are thinking to spend millions of dollars against a full team, creating a full team, keeping them for 1 or 2 use cases, and that is also supervised, not a very critical one, you just need few thousands dollars to use this tool and achieve the same goal. If you don't trust my word, the whole team is asking you to challenge us. We are asking you to challenge us using just give a sample data. The constraint is you should have a data with you. And if you're not sure to organize the data, we will not charge you for any money to organize the data. That's a free service because we want you to challenge us for any supervised case to see whether one day to give you a machine learning output is really possible. And the cost, the thousands of dollars, say $5,000, $10,000, is it real or is just artificially a company is saying in front of a lot of people? So here I like to stop. I like to hand it over to Emmy for a question answer session. Our technical panel will be happy to address your questions. And we are here for not today, tomorrow, you can contact Emmy. We'll be happy to help you, whatever possible from our side. Thank you so much.
Thank you, Sangramitra and Abhijit. So now we're going to turn to our Q&A session. We have some great questions here. The first one, Anish, this is for you. Is it a complete black box? I mean, can we see algorithms, active features, all kind of data analysis used by the AutoML platform?
Okay. Hi, everyone. Thank you for joining this session. Actually, this is a very good question and very common question nowadays, but this is not a fully black box. There are some features which makes this AutoML more transparent, like data garden, model explain, and the feature importance, iteration list. In the data garden, user can get an idea of what are the pre-processed steps are applied to the trained data, like null imputation, high cardinality check, and the class balancing detection, etc. On the other hand, feature importance show us what are the most important features that are effectively related to the target variable. So these AutoML features are make this process transparent and very much friendly to the user. Thank you.
Great, thank you. Ronak, I think this one is a good one for you. What are the pre-processing tasks necessary before submitting the data into any of your AutoML platforms?
Yes, that's a very good question, and thanks everyone for joining us. So the pre-processing tasks such as handling of missing values, categorical data encoding, balancing of imbalanced data, scaling of the data are performed in an AutoML platform itself. So no such data pre-processing tasks are explicitly required before submitting the data into our AutoML platform. The only requirement we have is that the data has to be in the tabular format with the label target variable. Thank you.
And there was a follow-up part to this one as well, if you could also answer this part, Ronak. Who and how is the train and test data separated?
Yes. The input data is not required to be separated into train and test data by the end user before submitting into any of our AutoML platform. Our AutoML platform does the splitting into train and test samples using techniques such as k-fold cross-validation to evaluate the performance of a model. Thank you.
Thank you. Okay, one of our other panelists is Joydeep, and Joydeep, I think this question is appropriate for you. For doing a POC, a proof of concept, what is the size of data you need? It also asks about domain knowledge, if that's needed, and do you need an expert as a support from the client team? So data, domain, and an expert from the client team. If you could touch on those, Joydeep.
Yeah, I mean, starting with the data size, right? So, so the platform itself, it does not take a data set which is less than 50 or 60 data points. So that's the minimum that we have to provide it. Apart from this, there's no limitation to providing data set to the platform. So it pretty much consumes anything and everything that you give in. Also, we have to make sure that the label is correctly pointed out. I mean, the target variable is correctly picked. So that's the only exercise we perform before we sort of push it into the platform. Coming to the domain knowledge, yes, I mean, like any other software project, we do need domain knowledge for machine learning projects as well. I mean, if you don't know what exactly where we are heading to and what exactly we are trying to do, there's no point doing a project, right? So yes, so when we sort of start a machine learning project, somebody from our team generally, liaises with the business user or an SME from the client side, and sort of a transfer of learning happens, and this person then acts as the internal SME for our project. And in case there is any problem, we sort of correspond with the client team and get clarifications on as and when required. So yes, domain knowledge is very much required. Even when you are selecting feature importance, once the platform comes up with the important features, it's best that we sort of validate that with the client, because the client might have a different perspective altogether. So if the client sort of agrees with the features that are selected by the platform as important and it matches, then we have a go, right? And if it does not, perhaps there is a problem, we need to drop a few features, or maybe we do not need to put weightage on them. So those sort of stuffs happen. But yeah, I mean, if the transfer of learning is really robust enough right at the onset, we have a pretty good project and we can expect very solid results. Yep.
Thank you, Joydeep. Anish, another one for you. I think this is a good one for you to answer. Can we use AutoML for unsupervised ML work?
Yeah, as Abhijit and Shanghamitra already discussed about that AutoML need a supervised data set. So for AutoML, we need to supervise the data. Supervised learning is needed actually. So not unsupervised is not applied for AutoML.
Okay, great. Ronak, another one for you. Why
Yes,
only Google, H2O, and Microsoft? What about AWS?
yes, ma'am. That's a very good question. So currently we have only Microsoft, Google, H2 in our platform, but we have already started working on AWS platform and we'll try to incorporate in our next webinar. Thank you.
So may I add one line here, Amy? So when we started this journey, other than Data Robot, no one was doing good in AutoML. And like normal cloud provider, Microsoft was ahead, and then Google is following up with Microsoft, like a very known. And H2O is getting popular. AWS is not there with they don't have the intention to address the machine learning, especially AutoML market. But now we see that they are coming up with a specific module to do, say, forecasting or time series analysis. So now we are seeing that AWS is coming up. So our team is internally checking their performance. So once we see that this is good, we will add that AWS platform along with our Google, Azure, and H2O together. So we will have all four best and data code together to address the AutoML marketplace.
Great. If anyone is having trouble with the chat, I'll pause for a second if you want to unmute your microphone, and you can also ask a question just in case anyone was having an issue with the chat function. Okay, Joydeep, this one I think is good for you. Can you develop data visualization components for us?
Yes. Yes, I mean, the data visualization is not part of the platform though, just to be clear. But yeah, we have a separate team who specialize on data visualizations, creating dashboards, and on Power BI, we have competency in Tableau as well. So yes, but it's a separate, it's separate from the machine learning platform that we demoed today.
Great, thank you. Anish, one more for you, I think. How does the system choose the right ML algorithm for somebody's data?
Okay, so as the name suggests, this is an AutoML platform, and that all the algorithms are chosen by the system automatically.
Yes.
Got it. So just so everyone understands, and almost everyone on the call, I'm sure you do, but yes, that's the point of the platform, that it gets the algorithm for you through the data. Did I state that correctly?
Right,
Yep.
right.
Okay. Ronak, this is a little bit similar to the other question, but it says, hi, I already use H2O. Why do I need to use your platform?
Yeah, because it's a very important and useful question. We have provided a very user-friendly interface for the H2O platform. If you see the H2O, you need to install Python in your machine and use that. but we have already done that for you and made a web interface for that purpose. So it will be very easy and very user friendly for you to use our platform rather than using the native libraries and the Python code. Thank you.
Yep. Great. Okay, Joydeep, another one for you, I think. We have 3 people in our IT department. How do we get started?
I mean, like I've said before, I mean, more important thing would be to understand the business, of course, and also to integrate the data from your platforms, from your environment to our environment. So, setting up the bridge between your platform and our platform would require your IT team, of course, and to understand your data, how your data is residing on your platforms, what exactly it's used for, and somebody who is a subject matter expert can help us with understanding the story that the data is telling. So if it's from an IT team, so yeah, I mean, we will need some engineers from your side, who would be helping us integrating our platform, building the bridge, understanding your data, and that's it. Nothing else we need from a client team.
Great. This one is kind of a similar one, but on the other end of the spectrum. So Joydeep, I think maybe this one is for you as well. I already have a team of 10 data scientists. I'm investing a good amount and getting a fair return as well. How would your platform add value to my current stack?
Abhijit, I think alluded to that. We had a project. Yes.
Yes. Go ahead.
Yes, I mean, we had already had a project that we sort of did predictions for a company, and he sort of reached out to another vendor to get predictions. So what a platform essentially does is it sort of offers you comparisons, right? So if you already have a prediction in hand, then what you can do is you can offer us the data and we can give you predictions based on those data, and you can compare. And we can show you how we are sort of reaching to that prediction, right? And so the kind of procedures you have followed to come to that prediction, we can show what we are doing, and perhaps either you or if we are better, then you can perhaps tweak things here on your side, and if you're good enough, then fine. I mean you can sort of come to us, and then you can keep on with what you are doing.
Yeah. So massive message is what Joydeep is saying exactly. We are saying you are good. We are not going to say that they have done something wrong. They are excellent. They have performed very well. But what you can do, giving the data and just spending say a couple of $1,000, you can have the result from our system so that you can also compare that with another tool to make more confidence building. So we have seen in our project that our data scientists created 95% accuracy using their own technique for last 5-6 months. But when they have given the data to us, we single day, we got exactly close result of what they are doing. So the use cases, now they have 2 different results from 2 different organizations or 2 different groups. One is like data scientist group, one is AutoML group, and they feel very confident that they have done a very good job together.
Yep.
Great, thank you. Ronak, this is a question for you, quite specific. What are some examples of use cases with this platform and FB profit?
Yes. So as far as use cases are concerned, we did a lot of use cases, including in the healthcare domain, in the manufacturing domain, in the retail domain, and for the using FB Profit, it is basically used for time series forecasting, and we have used FB Profit for forecasting the sales price, for predicting the future sales price. Thank you.
Great. Any other follow-up questions from the audience? Feel free to unmute your microphone as well. Okay, one more here. Anish, maybe this is for you. If not, you can pass it along to someone else, but what is ACI?
Yeah, actually, this is Azure container where we can deploy our based model, and this is only for the testing purpose. But in the production, we used and AKS for the production. Thank you.
Okay, cool.
And if I may come in,
Yes.
so
Yeah, sure.
yeah, I mean, yes, I mean, so ACI and AKS are two sort of SaaS software services offered by Azure. What ACI does is it sort of is a single instance of a container, generally deployed as a Docker container. So why it is used mostly in pre-prod environments, because it's a single instance, and you don't want to spin up multiple instances in your pre-prod system because it will incur cost, right? And why we use AKS for the production. So what AKS does is you can use multiple instances of ACI or containers for that matter. So when you have multiple instances of containers running, even if one goes down, you have one available. So you have high availability there. So there are many other benefits of using Kubernetes.
It's also load balance. It also load balance.
Yes. So yeah, so it has a load balancer, it has a gateway, and the load is distributed among different servers, and you can do microservices as well. So all that stuff can be done in Kubernetes, and that's kind of the benefit that we sort of leverage on while deploying machine learning models in production. So yeah.
Great. Another one for you, Joydeep. Who is doing the CI/CD scripting?
So yeah, I mean, we use infrastructure as code. What that does mean is, so we write what exactly sources we would be using inside the Python code that we write for creating the models or doing the feature engineerings, validations and all the stuff that we do in the same code base. We sort of write the resources that will be used, and that is fed into the DevOps process, right? So when the DevOps process runs as a task, it will see what exact resources are being indicated in the code, and that way you can sort of automate the whole deployment process, right? So it is scripted inside the model source code, in the Python source code, and it's deployed in Azure DevOps, and thereby you can sort of automate the whole pipeline right from the data ingestion till the deployment process. So yeah, so it is done by us, in short.
Thank you. Okay, Ronook, I think this is for you, but it's a two-part, and Abhijit, the second part is for you. Actually, maybe all of this. Okay, how long has the solution been generally available? And who are some of your current clients? Just noting we might not be able to say them on this recorded call, but we can always offer references. But Abhijit, over to you to answer both of those. The
question is how long?
Yep, how long has the solution been generally available?
Generally, it's available. It's all 24 hours actually. Our solution, right? He's asking about our AutoML platform. Yeah.
And probably how long it's been in the market. How long have we had it up and running for clients?
Oh, it's kind of 1.5 years, I should say. And there are cases we have one project with manufacturing, we have one project with healthcare, we have one project with retail. And there are a couple of proof of concepts still going on, because as when I was speaking, I was talking about assessment. So a lot of companies are contacting us. They want to spend like $10,000, $5,000 to just asking us to do an assessment. I'm just thinking those as not a real project, those as kind of proof of concept that's happening. But we have completed almost 4 projects using this AutoML platform already.
Great. And I'm not sure if you said, but finance, that's the fintech company.
Yeah, finance. I'm sorry. That's what I said 4. 1 manufacturing, 1 retail, 1 finance. Yeah.
Okay, so we were ending our session at 12:15 to give people the extra 15 minutes to get to their next event. So we're going to close out here, but we thank you so much for your questions. Oh, here's one good one that just came in, Abhijit.
Sure.
Do you offer free trial proof of concept?
Yes. Answer is yes. And you know, that's why I challenged you to give proof of concept. And at the end of the session, you will have Amy's email address and phone number. And if you have real need, immediately contact her tomorrow. We'll be happy. So the expense, what we have to do is kind of our infrastructure and services. We are ready to spend that expenses for you.
Great. Perfect last question. So yes, we're so excited to talk to any of you about potential use cases. I will be emailing out the recording, so you will have my contact information by email as well. And thank you so much for joining. Enjoy the rest of the Philly Tech Week conferences, and we hope to talk to you again. Take care. Enjoy the rest of your day.
Thank you. Thank you all.
Thank you.
Thank you.
Thank you, everyone.
Bye,
Bye.
everyone.
Bye.